You can't detect anything to do with the orbit on Earth. We just went through that, but like basically what they did was they went so over the top trying to be so precise and get all the measurements that they calibrated with such an insane sensitivity that it just threw so much noise in the data and then auto corrected that it was effectively useless data.
They
Bob's
wouldn't
data,
show it. They came back. They just reported, right? I just remember them reporting. Yeah. I don't. They didn't teach us laymen like, look here, look here, look here. They just testified.
So Stone does the best breakdown of that I've seen, where he goes thoroughly through all the data. Stone from Ether Cause, and he shows the issues with it. But yeah, I mean, anyone claiming that you're detecting anything to do with the orbit is insane. All I know is like I haven't gone like fully deep dive into gyro compasses, right? I understand that they work, and downward vector is not exclusive to anything. Inertial forces of rotation is not exclusive to anything. Like same with the pendulum, same with the gyro. And then as we get higher and higher, like when we detect rotation, it increases with altitude. Like throw Bob out, but Dayton Miller did that, And so I like we can detect the motion of the sky rotating around us. I don't really. So if you imagine a plane Earth with a rotating universe around it, so it has like a vortex centered on Earth, then there's going to be an angular vector to that rotation. It's going to correspond to latitude, and you're going to have real inertial forces translated down to the Earth. None of this would be exclusive to a spinning globe if it all works like exactly like it said. But I know Alan is like autistic when he decides to look into something, and he's gonna do a presentation on it soon. So like I would just watch what he presents and then go from there. I'm not gonna deep dive into it just to overlap with him. He's supposed to do a Prezie on gyrocompasses in the next day or so. So
Thanks, man.
yeah. Yeah, but the orbit claim's crazy, bro. Like Eggshells kind of venturing towards that. Like I've had a couple other people try to tell me that. Yeah, and it's like, dude, it's just that is fundamentally against what relativity says. It's literally impossible to detect anything to do with orbital motion. No forces, nothing like that.
Well, the rotation is my claim, and that's the one that needs addressing.
Hey,
gyros work, and is it just one more day? Is the only question worth asking on
Yeah,
that.
in your world, Earth is rotating around the sun.
It's relativity. It's just an object rotates 365 or 366 times, or sorry, 364.
No, that's just based on the Cypher day. That's all it is. But it's fine. Yeah, like the rotation, I've addressed it. Whatever you just say, no, it's fine. But you should be happy because I've heard you talk about this for 2 years, or at least. Alan's gonna supposedly fully cover it, so he said he found some crazy stuff.
I'm going to guess it now. We will spend so little time talking about mass, rotational velocity, inertia, gyroscopic forces, precession, and rotation and necessary consequence of being on a rotating body. And all of it will be is the same as it is today, which is endless discussion about irrelevant relativity shit.
I'm glad you know relativity is
relevant. That I'm gonna call it now and say Alan. I'm gonna call it now and say Alan understands the gyrocompass at least 20 times better than you do.
Sure, I believe it. I just think we're going to end up talking about something else. If he understands it at all, he will not.
I think he'll still man the gyrocompass from the globe like perfectly well. He does that with everything.
Still man it, yeah. I just don't think we'll spend much time talking about spinning masses. I think we'll talk a lot about exactly what you have: fringe shift and Planck length conversions and all sorts of esoteric, mysterious, theoretical physics.
Because you're ignorant about things doesn't make it.
Just
why the fact that it's rotating makes it line up with the linear axis? Hey, what's the fundamental mechanism?
I would say it's like I could feel it better than I could show it, in that if I had a spinning mass and I felt the gyroscopic forces or the precessional forces from tilting it, and you said, hey, if you were on something spinning, do you reckon you could line those up? I think I would go, oh, not the first time. But if you gave me a couple of $100,000 and a bit of time in my garage, I could figure that out, yeah. Could you make a thing that detects rotation? Not a gyro compass, I just mean a thing that detects rotation. Once I'd figured out gyroscopic forces, I could do that, yeah.
Yeah, but Earth is rotating around the sun, and you can't call it linear. You can't call it a linear orbit without relativity, and you keep abandoning relativity.
I don't abandon it. I say it's probably true, but I just don't need it in my argument. I don't invoke it. You guys do. It's not related to rotating objects. Can you tap in, Ruhif?
The only
You
way
think
you
it
can call
matters
Earth's
if you're
orbit around the
looking
sun
at something.
linear is because of relativity, right? So it's actually a rotational motion,
No,
like
because
a
I
like
don't
a
think it's
ball
even
around a
needed.
tetherball pole, right? It's a rotational motion.
Magic way to
So
make light
classical
shift if
mechanics,
you were looking at it.
you'd have observable effects from that, right? So you
The
need
light
relativity to
magically
explain
knows if
why
you're
we're not
looking or not.
detecting any of that.
So I don't think you need relativity until you get outside the solar system. So I just disagree with that. I think that the idea
So you
that
can
mass.
explain MMX without relativity is what you're saying, which everyone knows you can't.
No, if I was saying that, I've got a neat trick, and that is I say it, but you
Right, well,
change
that's
the
an
topic.
experiment
You
that took place
always
on
won't
Earth. So what
discuss
you said
what the
about
topic
only
is.
needing relativity beyond Earth or any terrestrial experiment was just, that was wrong.
I didn't. I just said it's. I don't think you need it to explain anything until you get to the edges of the solar system. Really,
And where did MMX
obviously
take
within it
place?
you
It took
do.
place on Earth, right? It was a terrestrial experiment, right?
Sure. So some things do
So you
become
do
relevant.
need it for Earth. So
I
you do
don't
need
need
it.
it personally. I mean, satellites
Right.
need it, but
Well,
I
it's
don't.
relied upon. It's relied upon to explain why Earth is in orbit around the sun.
Sure. I don't need it for what
Without
I'm saying about
relativity,
the
you can't
rotation.
explain that, right? So you can't explain
Sure.
like the
I
basic
can't explain
fundamentals
things
of
that
your
aren't
model.
related to my argument. Yeah, they're not part of it.
So I still don't get the answer about. I mean, you said you could feel it better than explain it. I mean, I still don't understand your answer.
Do you think a gyro on a plane could detect that it's doing a barrel roll?
Sure. Yeah, I can keep its position in free space.
Sure. So at what point, how slow a barrel roll do you think would be impossible for an infinitely precise gyro to detect?
Is this series of questions supposed to answer my question?
Well, we're reasoning to it, which is,
I'm not sure.
I think that 15 degrees an hour or one rotation a day is detectable. Do you think that we can detect a quick barrel roll? What's the slowest barrel roll you think before it's impossible humans could detect it?
I just answered.
Oh, what is it? What was the answer, sorry?
So I'm not sure.
Okay. Do you think it could be like if you did a rotation and it took you half an hour, we could still detect that with a gyro?
I'm not sure.
Maybe. What about if I could show you gyros online sell for tens of thousands of dollars that give you this number about how precise they are? Okay. Do you think that if I found you a $15,000
you think you can just explain it and stop asking me questions?
Sure. I think that if I found a $15,000 gyro and it didn't detect with very high precision like it would say on its specifications, I could just buy that gyro for a minor cost and sue that company for false advertising because they're selling a device that doesn't do what they claim it does. So I think just by knowing that gyros claim to have very high precision, you can be quite confident that they have such a precision because otherwise they'd get sued. They wouldn't be in business. They'd be selling lie devices and very good. So do you get the reasoning I'm making? If gyros exist that claim that they measure that precisely, it would be wild if they weren't correct. Or do you think gyroscopes?
I mean, everybody thought MMX would have been decisive. Like nobody, Einstein, Michelson, Moreland, everybody thought it was going to be decisive. They thought it was even more precise than it needed to be.
The question is about gyroscopes. Do you think that gyroscopes could be a lie, or when you find them expensive?
We're talking about gyroscopes. You can't even explain why it precesses off the Earth's surface. You don't know how gravity affects it. Like,
I don't know what that means.
You're just out of your depth.
Yeah, I'm out of my. That sounded like it not related to what I was saying. Didn't answer my question. Just said some weird words. Do you think that there is a minimum amount that a gyroscope couldn't detect? Like, what about if you did one revolution every 10 years? Do you think I think it's probably impossible to make a gyroscope that precise. It could measure one revolution per 10 years. But maybe they could, I don't know. But I'm going to guess that they could detect one per day. Would you agree that it is possible that there are devices out there that have a claimed precision of more than 15 degrees per hour?
Is this your way of explaining how it works? Just continuously ask questions?
Oh, I said how it works. Talk.
Torque is one word. That's not an explanation. Would you be
Okay, so rotational.
satisfied if you asked me for an answer and I gave you a one-word explanation?
Okay, rotational force. Rotation is applied to it through whatever, and that is how the axis can be brought. It can intake those newtons of force, and that will cause it to seek or like hunt or feel out of kilter until it aligns with the axis of that torque, that rotation.
So if you fly west to east, would it process quicker to find north?
Yeah, so it's you've got to you also should put in the ship's heading and speed, because if you're sailing east versus sailing west, you are doubling or halving not doubling or halving, but doubling the difference fore and aft of the Earth's rotation. Yeah.
I just do we have proof of that happening? Do we have proof of that happening? Or just
commercial shipping?
Yeah, the processing quicker part. If you go with the rotation of the Earth.
I don't know about it processing quicker. I think I think it is pretty good at staying locked on, like always pointing north. It doesn't suddenly point to the west. It just does a hunting move, I think, more.
There's a measurement that Wolfie did, Eggs, that he weighed an object traveling east and weighed an object traveling west, and it weighed less traveling east.
That's interesting because it's going downhill.
If you fly against the rotation of the Earth,
higher centrifugal force.
Go pretty quick. Would it not process at all to find true north if we're flying against the rotation of the Earth?
Say it again, sorry.
If we're flying against rotation of the Earth, will it not process the north?
Yeah, so essentially you could cancel it out entirely. If you took a gyrocompass on a plane and then flew eastward at the equator, staying with the rising sun, it just wouldn't be able to detect any direction. It would have no access through it. Yeah, I don't see how that would come to pass, but it would be good proof. But I don't know anybody who could do it that could be trusted once they did it.
So just so you know, it was processing when it's not attached to the rotating surface. Gravity is moving the plane.
Say again.
Like, what was your explanation? How is the mechanical gyro processing when it's not attached to Earth's surface? For example, like in a plane.
Yeah, that's what I'm saying.
Gravity's rotating the plane and the gyro, or what?
Yeah, so you'd have to account for its change. If it's cancelling out or adding to the rotation, or it's going to be moving from A to B, that will affect it, yeah, because it'll be moving in a linear path across a curved surface, so it'll be doing a part of a rotation itself. But it's like vector addition, where you just go, well, if I'm tilting and rotating this way and I'm moving in a path that's rotating me that way, I think you just kind of angle out. What do you do there? I forget. I think it's just you angle out. It's like vector addition, but with an axis. How do you do that actually in physics? But yeah, it's just
because I thought like the mainstream explanation was the plane is within Earth's gravity well, so it's,
that's not mine. No,
ever so slightly rotating the plane and the gyro. That's how it's processing.
You'd have to go with the person who gave you that answer, because I don't give that answer. You're going to have to deal with my ones. I'm sorry.
So it's just like the momentum. So you take off in one direction, and then when you change directions, it's not going to process anymore. In your scenario.
I think so. Yeah, I think if you took off at an equatorial airport heading east, a gyroscope and a gyroscope would detect no rotation, and a gyrocompass would not. I don't know what it'd do. I don't know what its behavior would be, whether it would just keep going around in a circle or just kind of do nothing. Whichever way you spun it up, it stayed pointing. I don't know what it would do, but you would have cancelled out the one torque or force that was being imparted on the device that was letting it find
something. So they're useless pretty much in planes. Like gyrocompass are useless in planes.
Yeah, you wouldn't use it in a plane. You use a ring laser in a plane.
I mean, I was Googling, it said gyrocompasses still process in airplanes. They use them on airplanes.
Oh, okay. What airplanes do they use them on? Because I thought they were quite sensitive to vibration. They don't like changing vector or sort of orientation quickly, I thought. Which is what planes do, right? Where are gyro? Where? There's going to be some cool use, isn't there? True mechanical gyrocompasses, are rarely used in standard airplanes. Yeah, directional gyroscopes might be what you're thinking, which is when you start up the plane, you'll lock this thing onto north and swizzle it for declination, but then that track is held by a gyro. So it's a gyrocompass, but it's actually a gyroscopic heading indicator where it just stays locked on where you teach it on the ground.
So that wouldn't persist due to Earth rotation.
That one, all of them must detect it. Like a torque goes through everything. It's just gyroscopes are better at detecting it. But yeah, it wouldn't be a good tool for detecting Earth rotation, I don't think. Because I think they have certainly the one that's the attitude indicator or the wing to tell you if your wingtips are level, that has some extra little vanes or lets air in some funny way that means that as you turn it just keeps averaging out, I think, what down is, what level.
Yeah, I'm seeing that older airliners, Boeing 737, 747s use them. I guess the modern ones, they use laser gyros now.
Yeah, they could have used them in back in the day.
So but yeah, mainstream already has an answer for it, so no need to.
Yeah, it does. The Earth's turning.
Right, so the plane is within Earth's gravity while everything's slightly being affected
to your
by that
one,
rotation.
that's not my answer. I'm not. If that's it, you'll have to go and talk with Mr. Mainstream. My answer is that the plane's flying level, and if that level that it's flying level to is turning, then it'll turn with it. And
When you're not attached to Earth anymore, you're not going to be detecting Earth rotation.
Right, but is the Earth still turning?
It doesn't matter.
Okay, so you've taken off and you're a tiny little speck of dust on this giant turning thing. And then what would happen next? If the Earth was a turning ball, what should happen?
Like you said, the gyro's going to keep its orientation in 3D space, irrelevant of the Earth. See, if you were on the Earth and the Earth was turning, it would go, oh, look, we're turning. But now, since you're in the plane, it's going to tell you what the plane is doing relative to everything else in the universe, all the way to the edges.
Yeah, actually, sorry, you bang on. Exactly right. Yeah, so the ring laser gyro, when the plane takes off, is locked in its orientation and will detect its path, the average between its path over ground and the rotation of the Earth and any other rotation it goes through in that flight, such as like banking.
They've tried to use gyroscopes to see if the Earth is round or flat because, gyroscopes, not talking about gyrocompasses, I'm talking about gyroscopes. Their job is to maintain the rigidity in space, right? So if the Earth is a globe or if it's curving, then the gyro should technically, right, maintain its rigidity. And as you start to move around the curve, the gyro will start becoming slanted and more slanted and more slanted.
Yeah, but that doesn't actually happen. Right? There's difficulty with that because you should also be turning with it at 15 degrees an hour, and it would be difficult to cross an ocean so quickly that you would see the tilt from the curve of the ocean that wasn't completely overshone by the tilt of the turning in a complete circle over 24 hours. Right?
Yeah, you're talking.
But what you do get in these devices is exactly that. So what I expect you would get as a raw readout if you read a long haul flight log is you would get all of the tilt and rotation and turn of the flight path, but I think you would detect that flight path is curved in an arc nose down, and you would detect that the Earth has turned during that time such that there is a standard eastward 15 degrees an hour. All of that.
No, yeah, but that's a separate argument. Now you're talking about the torque of the rotation. Right? We're not talking about the torque right now. We're just talking about what gyros normally do is keep their rigidity in space, right? Now we can talk about the rotation. That's like a non sequitur. It's what I'm talking about. Because just the gyro alone, right, should be turning it would be perceived to be turning as you move around the curve, right? But it doesn't do that. If anything, that would be a proof for flat Earth. The torque.
Again? I've not followed.
The torque is a separate topic, right? The gyro could still precess, right, and also keep its rigidity in space.
Dude, okay, this could be wrong, but I'm reading that
I don't know what that means.
for the horizontal north-seeking Earth rate component at the equator, it is always 15 degrees per hour, regardless of whether you fly east or west, assuming you remained exactly at the equator. But they do have a wandering effect that will happen whenever you're traveling east or west, like an air correction mechanism you have to apply, but that doesn't apply at the equator.
Not sure that's true. I think it does apply at the equator. It's least to the equator because your diameter is the biggest, so you're traveling the fastest. So if you were traveling like 300 kilometers an hour, let's say, at the equator, you'd still be traveling 700 kilometers an hour the other direction. So its effect would be tiny. But if you were traveling 300 kilometers an hour, latitude way down south, the lines of latitude are much smaller. So yeah, it's got a big effect at what latitude, in what heading, at what speed, because that will be affecting the rotation, either adding to it or subtracting from it.
Look up if the precession or torque is always 15 degrees per hour at the equator, no matter which way you travel.
I don't know what that means.
It's
we just talked about if the north.
It doesn't sound like what I said, though. I don't know what you're testing.
Why are you talking over me after asking the question?
Sorry. Yeah, what are you testing? What's the question?
Remember how the precession rate is 15 degrees an hour to find true north at the equator.
Right.
Okay, remember how we just talked about if you fly east or west to east, if that would be affected, the ability to find true north, because you're moving and spinning away from the Earth's rotation.
Yeah. So if you cancel it out, my argument is if you flew eastward at 1,000 miles an hour, so roughly you just kept the GPs, flew in the sun's GP, let's say, then your rotation would be 0, and the gyrocompass wouldn't be able to find north, and a gyroscope would detect no rotation.
So there is a wandering effect where you're traveling east or west or east, so they will take into account. But apparently at the equator, the direction you're traveling does not affect the precession rate.
Yeah, well, it's wrong, or you've asked it a weird question, I think. Or I'm wrong, but I don't think that's right. Yeah.
Hey, you guys are still going on about that, but I know Jesse, the Path of Light, he's talked about, we've had this conversation multiple times before regarding gyro compasses, and the argument is the reason that the gyro compass doesn't become slanted as you travel or traverse over the Earth is because the bearings aren't fluid enough. Right? It requires like a really I heard this the excuse was that it requires like a really expensive gyro, and the ones that you can get like on Amazon don't fit the bill because the bearings aren't sensitive enough, so it doesn't actually pick up the
but I think
whatever it is.
If you wanted to know it, I think first step is you would just compare a very expensive mechanical gyroscope to a very cheap fog, and go, because a fog you can buy, if you want to do a bit of Raspberry Pi and build something yourself, a fiber optic gyro you can get as a little chip, and they go in drones and RC cars and phones and all sorts of stuff. So they're really easy to get, which is just a gyroscope that tells its change in orientation in 3D space, and put that into a board. And if you test that against an actual gyro, and
those are gravity based, man, if they're that tiny.
But if you just become convinced that a fiber optic gyro works, then you can just use a fiber optic gyro to test it. You don't need the.
But eggs. But you see what I'm saying though? Like you're talking about antipodal, right? If you've traveled from one position of the Earth to the other position, antipodal, and the gyro keeps its rigidity in space.
Yeah.
Theoretically, right? If you're on a globe, the gyro would basically would be upside down by the time you got to the other side, or not not entirely upside down, but pretty much. But that doesn't happen.
Able to work out your latitude.
Pendulous
vanes.
That does
happen.
Pendulous vanes correct the orientation to down.
Oh, in the
But
plane
apparently
ones.
there
Yeah,
was
the
a
plane
time
ones
they
are
flew without
mechanical.
pendulous vanes. They were patented after the
Oh,
first
right.
aircraft.
Yeah, but we're going back to the demarble thing. Like he said on there, didn't he? No, he had his phone, right? He was doing his phone, I think. But we're like pretending he's like spinning up a freaking rigid gyro. And I think Lion, you're saying Jesse said there was too much friction in these things. And that's why, like, I'm like, how do you keep them spinning for an hour? That's where I'm at. Like a rigid gyro, it ain't gonna do
No,
nothing.
if you do it slow enough, if you do it, you can actually tip it or whatever or spin it. If you do it slow enough, it'll keep its rigidity, without actually like like they demonstrated a video, dude. I don't know how to explain it. Like if you do it slow enough, right, the rate that you're traveling, it's so nominal that it's not gonna affect the gyro. It's gonna keep it's just not gonna move. You know what I mean?
Yeah. Zion, what do you think is the slowest rotation that you would trust a gyro to detect?
Oh my gosh.
Dude, I don't know, man. But basically, it doesn't work. At these scales, these gyros don't work. They're not sensitive enough. So, though they're supposed to keep their rigidity, they continue to actually.
Which ones?
The ones that you get on Amazon for a couple $1,000.
Oh, yeah.
They don't work because the bearings aren't sensitive enough. That even though it should keep its rigidity, it doesn't actually keep its rigidity in space when you go around the curve of the Earth.
Yeah, I think mechanical ones are a very expensive bit of kit for that reason, and that's why I'm saying if you just become convinced that a fiber optic gets the same results, then you can, anytime you use a fiber optic, go, well, I could get that $40,000 mechanical gyro to test it, but I'm so confident that the fiber optic does the same thing, I can spend $40 and do it in a weekend.
So
I don't remember
looking for a phase shift. It's not. I don't know if it's like north seeking. I don't think so. It just has a phase shift. But I was gonna ask you a question about the mechanical. How many revs per minute does it have to rotate to be effective, and why does it have to rotate so quick to find north?
Because it's a gyro. You're saying, like, why does a gyro have to spin? Is that the question?
What rate does that have to spin at to start working?
But is the question, why does a gyro have to spin? That's what it is. It's a spinning thing.
My first question is.
But she didn't ask you that, Riding. She said, "Why so?" She said, "Why so fast?"
Oh
I don't even know the RPM.
I'm still trying to get an answer out of him, dude. Like I don't even know. I really don't know the excuse. I'm trying to remember the excuse. I don't remember the excuse. Do you have an excuse for why the gyrocompass doesn't keep its rigidity in space when you travel around the Earth? Now I heard this guy talk about the vanes. Oh, let's say that it doesn't have vanes. What's your excuse then?
Like, I don't know. I think that if you've got a small gyro that's job is to detect moment-to-moment rotation such that in a whiteout it could keep the plane level, but it would not want to detect rotation. So it's the same question essentially Taylor was asking before. You're saying, why don't we build a device that's job is to tell him if his wings are level when he can't see the horizon? But why don't we deliberately build it in such a way that it's wrong after 12 hours?
No, just don't apply corrections.
Yeah. So why would you do that? Why would you build a device that was meant to do one thing and then make it shit at just that one thing?
So why can't you answer the question?
Because you wouldn't build a device that doesn't do the thing it's meant to do. Whatever way you build it, you're going to build it.
Okay, so we have to acknowledge the basic device can't do the thing. You have to apply corrections to the device.
What does that mean? You've got to make a device that works.
Not detecting anything.
What is it doing then?
You know exactly what it means. That the device in and of itself can't do the thing. Right, Lion? You have to apply corrections to the thing. So he's asking you, without pendulous vanes, could it still maintain rigidity?
Are pendulous vanes part of the device, yes or no?
No.
Oh, then we're talking about something else. I'm talking about an airplane gyro and we're talking about pendulous vanes, whereas an RLG won't have them. I don't think the ring laser gyro has anything that you call pendulous vane, but it isn't spun up with air, so it's a different thing. Like the ones in a plane are spun up by letting some air in the nose, and then the velocity of that air spins around a gyro in there, and then some of that air is like valves open and close over time, just gently bringing it back to a kind of average of what's horizontal and the vector of down, I think.
If you don't know the answer, it's fine.
I just did give you the answer. The pendulous vanes are part of what I would describe as the device, and they're there because otherwise the device would be broken.
Mm-mm.
What's the question if that's not the answer?
No, it's not the answer. Pendulous vanes are not part of it.
They're not part of what?
Lion, re-ask your question so I don't butcher it. Okay.
No, I was saying regarding not the gyrocompass, dude. Just regular gyros. If you're in a plane, dude, right? It's supposed to keep its rigidity in space. Why doesn't it keep its rigidity in space? And I'm not talking about the ones without being.
Yeah,
even like theoretically, if you were to use a $30,000 gyro, that was.
I don't know if gyroscopes have a vertical. You know, I don't know if they behave like
that. I just don't like. I don't understand the question when you're saying why don't they do that? When you say they, there are millions of kinds of gyros. So in any given
fundamental
plane,
nature of the gyro is to keep its rigidity in space, regardless of your orientation. Right? Once you set it, set it in motion. Right? Once you spin it up, it's supposed to keep its rigidity. Doesn't matter if you go upside down. Yet when you travel in a plane, it doesn't keep its rigidity. Why is that?
Yes, it does. It
does.
Because
we're on a flat Earth.
It does.
Could that be why, or is there another? You have an excuse?
Have you disconnected? I don't think he's. I think we're getting him through a different mic. I think his headset's gone dead and he hasn't noticed.
Nice.
Yeah. Have you disconnected from us?
Oh my bad, dude. I couldn't hear nothing. Was I talking?
Yeah. Yeah, man.
Maybe my headphones.
It does. All of them on any given plane might have 400 gyros on it at any given time. I've got no idea. The most precise ones will maintain their rigidity in free space. They'll detect everything from the rotation of the Earth to the, subtle tips as the wind hits it. And some of them, if they're trying to remain level, will not. I don't know why that would be confusing to anybody.
A ring laser gyroscope.
I wouldn't want to pretend to be confused by that. Say again?
A ring laser gyroscope does not keep rigidity in space. That's what I was telling him. Actually, something useful.
Ring laser
gyro. Thinking of the gyrocompass.
It's meaningless to say that.
Yeah, ring laser gyro doesn't work on gyroscopic or even physics forces, or like Newtonian physics forces, I would say.
He was saying not the gyrocompass, but you'd have to be referring to the gyrocompass for your question.
No, just any physical mechanical gyro. Because there's many on planes, right, that help with the heading.
He was asking about keeping rigidity in space.
Which is what physical gyros do. Yeah.
What kind? What are you talking about?
So a physical gyro is a spinning mass, and they want to maintain their rigidity in space. So that's just like kind of gyro. And then the scopic part is then we use that, hey, that thing tipped left while the whole plane was fine. Maybe the plane actually tipped right. And so you then put a kind of dial or some sort of readout that tells you what the gyro says. And that's how you now know.
Okay, a ring
gyros.
Bro, finish.
I was answering the question you asked. You interrupt the answer and I stopped. Why would you bro me?
Okay, yeah. If you think you're adding more content, then continue.
No. I was fine stopping. I just didn't understand it. You asked me a question. I was midway through answering. You interrupted and I stopped. And you're like, bruh.
Yeah, I'm trying to.
Okay. Go for it.
So, like, whenever you say they're all spinning things, that's not true. Like a ring laser gyroscope is exactly what it sounds like. It's a lasers that go in a ring. So whenever you say keeping rigidity, a rotating body, like these are lasers. You know what I mean? Shooting in a circle, and whenever they're rotating in one direction, the theory is it has a phase shift, right? So it has a phase shift, and you can actually mechanically rotate it and take a phase shift and see a Sagnac effect. But
does it detect the rotation of the Earth?
In terms of keeping rigidity in space, he would be referring to a gyrocompass because there's not a rotating body. It's just rotating lasers in a circle.
Sure. So any gyroscope, though, any like mechanical gyroscope, not necessarily just a gyrocompass is the point I'm making. There are many other mechanical gyros that do different things, like heading indicators and things that tell you whether your plane's doing a barrel roll.
So what would be the difference in a mechanical gyroscope versus a gyrocompass?
One finds north.
Yeah, but I'm talking about the structure.
So it compares the vector of down. It will apply the whole thing you're normally doing is it just stays locked and you compare the difference to that. Whereas what you can also do is put in a precession. That is, if something's out of kilter, it will reliably precess either left or right. You know, if you push down, it goes left. If you push up, it goes right. So you're trying to use that precession force, and then you add a weight, or it used to be oil, and it pulls down. And so the way I imagine it in my head is it's trying to like get the gyroscope to look down, if you will, because below it will be an axis of the Earth, and it will be out of kilter with that axis. So that if you keep pulling this weight towards down, when it goes too far past north, there's no more precession. It wobbles back and back and back, and then it crosses past north, and then it suddenly gets a torque applied to it and wants to hunt towards north. It will be out of kilter. You know, the net forces will be greatest when, you know, or even out when it's on north.
Every mechanical gyrocompass is a gyro. Every mechanical gyrocompass, hold on, is a gyrocompass, but not every gyrocompass is mechanical. No.
Every mechanical gyrocompass will be a gyroscope, or deploy a gyroscope. Not every gyroscope will be a gyrocompass.
Yeah, that was typo.
And it's, I don't know if it's right to call the fiber optic one still a gyro. It kind of is, but is it gyro? Where's that word from? Is that rotation or is that spinning? You know, maybe it's the same thing.
It's like on an axis, though.
Yeah, torque. It's around an axis.
It's so weird how some of them have precession and torque at the equator, and others don't. I'm gonna have to look into that.
Well, it's exactly what you would expect, isn't it? If the Earth was rotating, stuff would get weird at the equator.
Have the opposite effect, though?
Sure.
I don't
one's
get
turning
that.
left, one's turning right. One's, you know, north is south, south is north. As above, so below.
But yeah, but the Earth's spinning in the same direction, dude.
Sure. Yeah. That is left for some people and right for others. If you look at the pole, if you look at your central point.
Yeah, but that's perspective, dude. The Earth's spinning in the same direction, dude. The ball's spinning in the same direction.
Yeah, it's orientation. More than perspective, I think. Maybe perspective.
Just depends if you're looking up or down. But it is weird. When you guys say that Foucault's pendulum doesn't work in the equator, but it seems to still precess or drift. But Foucault's pendulum is supposed to be in a like an illusion, dude, based off the Earth's motion. Where it's not like an actual force. Go ahead.
Do you think it's possible that a gyro could detect like a really, really slow rotation that could be a good enough one that could detect that? Like if I said I've got this thing and it does it turns once a month. If I paid $100,000 for a really expensive gyro, it could detect that?
Well, dude, no, you guys already claimed to detect something, and I don't disagree. Yes, you're detecting something, and theoretically, if the Earth was in motion, you would detect it. Hypothetically, there's nothing wrong with that. What is the cause of this precession, this phenomena that we observe with gyros and compasses, gyro compasses? Even the torque, right, that you're talking about. Like I'm not denying that is an actual phenomenon, dude, and you can use it to pinpoint where north is, relatively speaking, within 10 degrees. Like I know that it starts to hunt back and forth, right? But you can average out, right, the hunting back and forth and know where north is. Like it's pretty But even regular magnetic compasses, like you got magnetic north, depending on your location, there's magnetic declination, but it'll still give you a direction towards north. Sure, it might not be like pinpoint due north, right? And it's the same problem with regular compasses. So I'm not like, to me, that's like a no point.
But it's not, my argument, just to clarify, isn't, oh, this works better than a magnetic compass, therefore it is, this is necessary on a globe. If you showed the gyroscopic forces weren't at play, you would disprove a globe. Would you agree with that? If you said, I've got a sufficiently precise gyro, it says it measures 1/100th of a degree per hour and it measures 0, you would have disproven spinning Earth, right?
It would falsify it.
Yeah, it would falsify it. Yeah, because you say we've got a device that we know is this precise. It's so precise that I could sue them in court and take their money, and it shows the Earth isn't rotating. But we get the exact opposite of that, so we get a complete nothing but net 3-pointer.
And that's why we're still here, dude. You know, because it's not that easy.
It is. It's just not that easy to accept it after all these
years. Yeah, but this is not as clear cut as you might be thinking. I'm just letting you know.
It's so clear cut. It's one of the clearest.
Tell me the mechanical differences in a gyroscope versus a gyrocompass. A mechanical gyroscope versus a gyrocompass.
Sure. Mechanical gyroscope depends what application you're using it for. So there are some in ships that aren't even, they're still called gyroscopes, but they are stabilizers, and they are a mass that is spinning that just counters the slopping of the waves. So you get out to a sport fishing spot and you go, and they spin up and the boat doesn't sway back and forth. And it's not even to detect anything. It's just so you can stand on a steady platform and do your fishing. And they go from there to in jets and planes and rockets and all sorts of things. And they're just trying to detect rotation.
How does a gyrocompass find north but not a mechanical gyroscope?
So a gyroscope will still find north. You would be able to, if you bought yourself a fog, like I'm saying, for $40 and stuck it into a Raspberry Pi, you could detect rotation and then from that compute where north is. Every gyroscope will still detect this same thing. It's just a mechanical gyrocompass is a clever way to put it on a mechanical faceplate that you can read in the dark. You know, well, when the power goes, not when the power goes out, but.
So one of them just has a Raspberry Pi?
No, I'm saying any gyroscope will detect the rotation, and from that information you can go, well, here's the axis and there's the direction, and I know which one's which, so I can figure out north from any gyroscope. You just compare it to your local horizontal and you go, what was going on between them? What was the angle? Where are we going?
I'm not even denying that it's detecting rotation, bro. It's just, is it the Earth's rotation or the sky's rotation? That's Witsit's argument, bro. And you kept like making it exclusive to the Earth.
What's mechanically different to make a gyrocompass find north but not a mechanical gyroscope?
So, like I said, like a mechanical gyroscope would still, you could infer north later, but it would just stay locked in a position and you would compare that change over time. And then from that, you could infer north. Whereas what you're doing with a mechanical gyrocompass is applying a torque that's pulling downwards, it's following the vector of down. And what that means is it's pulling the axis, it's going to cause a precession on the axis where it will be out of kilter unless it's best aligned with the rotation of Earth. So one, you could infer it later, and this one mechanically gets it now.
Most gyros precess naturally, like that's what they do in a circle. They keep their rigidity in space, but they'll precess. But if you put dude, it's been a while.
They can't be both.
It's been a while since we did this, but dude, no, like they can precess wildly. You got to kind of calibrate it and balance it out so it doesn't do that. It'll precess faster than the Earth. Like we're talking about within a couple minutes, that thing will start spinning around. Right? You gotta make sure it's balanced out, calibrated. But when you want to pick up the Earth's precession, dude, you're talking about a 24-hour period, dude, 15 degrees per hour. Right? So you got to sit there, and make sure that it's precessing at 15 degrees per hour. There's counterweights, dude. Like somebody brought up a ballast earlier, right? What's the ballast do? The ballast is the counterweight, right? That I think they filled with mercury or some shit. right? So to then pinpoint where north is. But without that counterweight, dude, how are you gonna pinpoint where north is?
Yeah, so I can't understand. It's the I need to explain the precession. Is that what you mean?
I'm saying if the gyro is precessing, right, in a circle, and it's not hunting, it's not doing its hunting where it bounces back and forth 10 degrees. How would you know where north is?
If it's you would get
if it's not hunting.
Yeah. I don't know. It would be locked ideally. It would just be the needle would be fixed on north. Is what I think the answer to what I think the question you're asking is. I don't quite get it.
Well, no, that's what
gyrocompasses all these questions are like. If the gyrocompass worked differently, and I feel that it's missing that my point is it works the normal way.
Hypothetically speaking, right, without including the ballast or the pendulous veins, right, just a regular gyro. The reason it's a gyrocompass is because it has extra parts like the ballast, or the veins, right?
Yeah,
basically that's what allows you to calibrate it so that you can pinpoint north. Yeah.
Yeah.
I think that was what Taylor was talking about. I know you got the gimbal, you got the ballast, you got. I mean, it's been a while since, dude, I'm driving, but you can pull up. You probably already did post a diagram.
I just don't understand the point. It takes a few parts, but to me, it's like going, oh, I'm not sure a speedometer reads because it's got a rotation sensor. It's actually got like bearings. It just sounds like you're sort of getting sus about the parts of a thing that does an incredible job rather than talking about what the job is and how it does it. Because the damping and the sensors and the this and the that would be valid if you said, well, maybe within the damping mass of comparing the vector of down, it has baked into it this vector of north or this axis.
I get that.
And that's how it does it. Whereas you're just sort of going, oh, here's a word related to a gyrocompass.
I get that, and that's why I said it's like a no point. I'm more interested in how it's able to keep its rigidity in space, or vice versa, right? As you travel around the Earth.
Yeah.
Like if you're saying it keeps its rigidity because of the pendulous veins.
No.
If you don't have the pendulous veins, they won't keep its rigidity. But we haven't.
Other way around.
Yeah, well, I don't know. We haven't done this. I want to see a video of this actually happening. I haven't seen.
Want to see a video of what?
Either or. What if it's a globe, right? Without pendulous veins, it's going to keep its rigidity in space, falsifying the globe, right?
But it sounds the pendulous veins. Let me just clarify something for you. Pendulous veins are this thing on a really specific kind of gyro, which is just that one that tells you it might be a heading indicator, but I'm pretty sure it's just your wingtip, your roll sensor, and it is spun up by incoming air, and that air is vented through these veins. That when it gets out of kilter for a while, these veins want to hang down. And so they will open up a little air gap that will then apply a torque that brings it back. So down stays as one thing where you can still do a barrel roll, right? And you're sort of testing, could we detect the rotation of the Earth using this really specific niche application of a gyro that has a part in it deliberately put there to defeat this problem?
Dude, I'm trying to be patient and charitable, dude. I'm trying to explain. I'm not talking about the rotation of the Earth anymore, dude. I don't even care about that argument. To me, that argument's like whatever, right? Whether you need a mercury ballast or not, who cares, bro? Like, I get it. You need counterweights. You need that for a regular compass. Just to find north, you need that for a regular compass. Counterweights.
Yeah.
Right. What I'm asking about is the rigidity, right? If it's a globe, right?
Yeah.
The compass, the gyro should keep its rigidity in space, and as you move around the globe, it should slant, and it doesn't do that. It doesn't do that.
Yes, it does. That's the bit you need to test. Yes, it does. You're just claiming it doesn't and that's necessary for your worldview, right? It would be wild if gyros that detect rotation worked, but they do. So therefore, you're going to have to either give up where the gyros work or give up the non-rotating Earth. But you need to know it's true already, because same as Witsit already knew that the Earth, he was going to see a 24-hour sun before he got on the plane, because nobody's doing that without it. Nobody's selling a gyro that can detect really precise rotation on a claim to be rotating planet and not worrying about that, because either they are bullshitting about what the devices do, or they know about the rotation of the Earth, or just nobody's ever bothered to check whether it shows rotation or not, or nobody's ever tried to use it for another application.
I want to see the video, because I mean, flat earthers have tried this, dude. They brought gyros on the plane, dude. Dude, that shit is not moving. That shit stays level the whole flight. It's not moving, dude. It's doing its function. It's keeping its rigidity in space, dude. That should be a flat earth proof. But you guys are like, nah. The reason it doesn't slant, right? It's either because the bearings
on a plane.
The bearings aren't sensitive enough, right?
Well, yeah, so it depends on how precise the gyro is.
It's not doing its function. Or right,
who's done it?
Gyros have the veins, so it doesn't do what it's supposed to. It doesn't make any sense to me, dude.
So I'm reading like that mechanically.
Nobody's done it with a gyro, is what I'm saying.
Hold on, a gyrocompass is a mechanically deliberated engineered control system with the let's see, like the bearings and the gimbals and a system to input latitude for corrections. That's the only difference.
I wouldn't say it's the only difference, no. But
what do you think
it does have those things, but that doesn't mean they're the only difference to me.
What's the other difference
to me is the main difference, as I see it, is the applying the torque in the vector of down. That's the difference.
How does it do that?
The maths that we're talking about was first done with oil, but it's just done with weights on one side, on a side of it. So it's not free to reorient. So it's not free to stay locked in space. As it tries to get out of being locked in space, it will apply a torque where that vector of down will no longer be down. So that's the main difference. But yeah, you also have to put in latitude.
Another stalemate.
I think this one's always a fairly strong wind. The gyrocompass is the strongest wind for the globe, I think. That and celestial navigation.
Yeah, but you have to introduce, like, it's not just a spinning body.
Sure, yeah, it's a whole device that finds the rotation of the Earth.
If you didn't have to introduce any corrections, it'd be a little bit more impressive.
What do you mean? What does that mean? Like,
if you didn't have to introduce corrections to find north.
Well, let's talk about another detection device. What would you say that about a speedometer or a thermometer or a I don't know, scale?
What are the correction mechanisms?
Many of them take calibration.
Eggs, the thing is, bro, if it was truly just like a natural force, right, where you wouldn't need to calibrate it constantly, it would just be 15 degrees per hour consistently everywhere. It doesn't matter elevation, doesn't matter latitude, but it's not, dude. Because you got the angular momentum and the angular velocity.
It's not 15 degrees everywhere.
How are they different?
It's not 15 degrees per hour everywhere, nor depending on your elevation, though it should be according to your model.
Well, it is. It is according to me. We're
according to you only.
Nope. No, nobody says we rotate, because that would be a non-fixed body, or we're behaving like a Rubik's Cube. I don't think we're rotating at different speeds, and that's what we require. Show me a single object rotating at different speeds.
Dude, the sun, the moon, the stars all rotate at 15 degrees per hour, right? You guys say that Earth's rotating at 15 degrees per hour, right? You should be picking up 15 degrees per hour regardless of your elevation.
Correct.
Right? Regardless
of
your latitude.
On your AI.
That's not what happens.
Venus spins the
Aren't
wrong
you
way.
not happen? Huh? Just look it up.
Look up what? Do gyros
And
not
for
work? Or what?
Gyrocompass detects a 15-degree per hour precession rate at every latitude.
What do you? Does a gyro work at the poles? Is that what you're asking? He's saying, is it 15 degrees everywhere? That's what I'm saying yes to. You're asking a different
No,
question.
look it up.
Look what?
At
Is it
every
15 degrees
latitude. No, it's
everywhere?
not.
What do you mean? What are you talking about?
Look it up.
Oh, now my sister's here. I gotta go. Yeah. No, it's 15 degrees everywhere.
Look it up.
You guys are... Yo, Eggs has been going all night, but I gotta give credit.
He won't even research it.
He got the stamina to go against.
Nothing is 15 degrees
Witsit.
per hour everywhere. From the equator, it's like for example with the ring laser gyroscopes or the gyroscopes, depending on which one, it'll be 0 degrees at the equator, just like the pendulums, and then have more precession towards the poles. But it seems like this one's opposite, where it has 15 degrees at the equator and less towards the poles. It's latitude dependent.
Yeah.
What that's picking up is the effects of the spin. The 15 degrees per hour drift is the rotation of the Earth, not dependent on latitude.
No, yeah, but this is the thing, right? On the equator is where you got the strongest centrifugal force, theoretically, right? But yet it lacks like detection on the equator. That's the whole point.
Pendulums.
The angular momentum is the greatest at the equator.
Yeah,
that's how centrifugal forces work.
The 15 degrees per hour is latitude dependent on the gyrocompass eggshells. Do you know that?
I think Eggs may have dropped for a second.
And who's counting money? An automatic counter. Is that Rene, dude? You counting money?
No, not today.
Putting wads in.
Should suck.
Yo, it's 6:30, about to be 6:30 my time, and Eggs has been going hard since like 12.
Okay, so a ring laser gyroscope is 0 at the equator and maximum at the poles, opposite of the gyrocompass.
Taylor, I don't know. I think you got that. He doesn't have a good response.
To which question?
Did you just hear me?
No.
The precession rate being 0 at the equator for ring laser gyroscopes and pendulums. And then 15 degrees at the poles, but opposite for the gyrocompass.
Okay, that's not a question. That's a statement.
I think Lion was asking why.
Yeah, I mean, if you consider just regular like physics.
Well, they're two different tools, so two different devices.
Even though it's called I'm trying to remember. So you got angular momentum, you got angular acceleration, and you also have translational motion, but towards the North Pole, right? Because it's smaller, it's going to look like it's spinning faster, and the equator is going to look like it's spinning slower, but it's actually spinning at the same rate, 15 degrees per hour, right? Regardless if you're at 90 or you're at 0 degrees. But at 0 degrees, even though, visually the angular velocity it matches the north, there's greater momentum, right? There's greater momentum towards the center of mass, or towards the center of rotation. Like when you put water, or let me explain like this, a visual representation. You guys all seen when you put water on a basketball and you spin it. Where's the water filling off from? Mainly
the middle.
The middle, right? The middle, right? That's a centrifugal momentum, right? That should be getting picked up by these gyros, these laser gyros, right? Because that's where the centrifugal momentum is the greatest.
Well,
Granted, it's 15 degrees per hour throughout. I get that, right? But the conservation of momentum, the momentum should be the greatest towards the equator. You guys following?
I think it is.
But yeah,
right?
Taylor's saying that according to her research, which I agree, it's same thing with focal pendulum. It seems to be erratic at the equator, like it's almost like a neutral position, a neutral point. Go ahead.
Yeah, I mean, it would be. It's like north of the equator, things start moving this way. South of the equator, it goes another direction. So it kind of is an equalization point. And I think it's because of what you were talking about the center of being the center of mass. But the thing is, it's like all of the atmosphere and all this other stuff. That's not what that's not what the gyroscope's picking up. It's picking up the actual movement of the Earth due to those pseudo forces. You know what I'm saying? No.
I mean, not kind of. I'm trying to, but like I get what you're saying. Where they might cancel out, but the thing is, you have to understand that the Earth is spinning in the same direction, regardless if you're in the south or in the north. The Coriolis effect is supposed to be an illusory thing based off of reference frames, right? That's why it's an effect, and it's based off of you got the rotating reference frame and the rotating reference frame. It's only an illusion because the Earth's actually spinning in the same direction.
North and south. That. I get what you're saying there. I understand that, but like I said, with the gyrocompass and the gyro whatever, the ring laser, they're just two different tools, so they're going to work a bit differently. But I think they like even in what you brought up, I think that one of them would like almost be the opposite of the other one, the one that's actually precise or something like that, right? But like I said, it's what's being detected is a 15-degree drift of the body of the planet. And the thing is, it's if you want to say this is ether, right? The ether that you're prescribing to is not the luminescence ether that people believe in. This is a completely different ether. So there has to be a bit of explanation of why does it work like this, like gravity.
Why is it completely different?
Electromagnets.
Because it doesn't illuminate.
Luminance. Did you know what the luminescence ether?
No, I'm asking you. You said it's completely different, but you didn't touch on any attributes of it being different.
Because I'm not. That's not part of my thesis right now. I'm trying to have a conversation.
I disagree with you. I've seen it enough to where they're bringing it back. There's no difference. Thanks, man. So
do you know? That's why there's no point in getting into that. But one of the things I'm saying is you have to kind of describe what these ether things are, independent of electromagnet, of electrostatic, independent of gravity, independent of these other things that have already been defined.
Weak force and strong force.
Did y'all know it drifts in different directions in the north versus the south hemisphere, the gyrocompass? One drifts eastward and one's westward.
Opposite. Yeah, makes sense.
thing you want the ether to be is
Same
the
thing
thing
with- same
every
thing with-
particle physicist wants everything to be.
Same thing with Foucault's pendulum, and same thing with hurricanes and tornadoes.
So that's what I'm saying. It's like you within the one paradigm of Earth, spin, gravity, atmosphere, all of those questions are answered independently of one another and are able to be mathed out. Like ether is not something that needs to be added to show the phenomenon.
So gravity is something you have to add.
You can't just use Newton's laws of motion.
Special space time. You have to add your space time.
No, so space time's only useful when you space time's really only useful when you get outside.
No, it's useful to give you gravity.
Solar system. It's useful to get a more determinate system once you exceed our solar system. But inside of our solar system, Newton is highly.
You're absolutely wrong, man.
Okay. I might be.
You need space-time dilation even here right on Earth. Like space-time is nothing. The point is this. You keep pretending like, okay, we've got these independent things and we don't need nothing extra. You guys need something extra. But you don't have the independent. You need something extra, which is this unknown gravity that nobody knows what it is. That's your something extra that you're pretending isn't something extra.
Okay, and your something extra is ether, which I said. Yeah, okay, then what is your something extra then? Nothing?
It's the same thing. It's all this. We're all at the same level.
No, that's the thing. So like if I like you
there's a point.
Like,
particle physics does what particle physics does, right? You don't need gravity for particle physics. You don't need Aether for particle physics, but you need the strong force and the weak force and all this shit, and they don't know where it comes from. So we're all at the same starting point.
No, not when it comes to why objects spin certain directions on the Earth.
You want to talk just about spinning, that dude? That's fine, but you don't need to bring ether into it. It could be like
so. My question was basically outside of gravity, spin of Earth, what other things? Because within that paradigm, you can find all the forces at play. You can do all of these things. You can isolate, you can eliminate, you can make variables. Mm-hmm. And my question was because I think the answer is going to be ether. And that's why I said
you weren't here all night, though, I guess. Man. Yeah, I'm
we spent all night talking about it, dude, but
it's ether, right?
Well, this is the thing, right? Like, when you guys talk about gravity as the cause for a lot of this stuff, even for gyroscopes keeping their rigidity, right, the downward vector. Gravity, according to relativity, isn't even a force. It's a pseudo force, but it's having real, it has real effects on matter, right? But at the same time, like, what mechanism is affecting matter, right, at a distance? Like, how do the bodies, right, of planets, how are they affected by gravity at a distance?
That's what.
Don't pick and choose Newton.
No. So with Newton, this is where Einstein came in. So with Newton, there's basically instantaneous actions between two objects, which is impossible, right? And that's why Einstein came up with this theory of space-time, which eliminates that impossibility, but still takes all of Newton's findings to get to that outcome.
I get that, but Einstein also had spooky action at a distance. Dude, right?
That's what.
So you scoff at us and you talk about ether. We don't need ether. We have space time, dude. And you're like, well, yes, we have space time, and act like that's a better answer to these natural.
But it does. Space-time lets you model. That's the thing. So with space-time, you use all the other old coordinates, all that other stuff. You still get accurate models and predictions of rotations of bodies, and you get actual model predictions of orbits. You get actual model predictions of everything. You have replicable results, right? With gravity, balls.
Not really.
Yeah, you do.
Not really, dude. No. If you consider the law of parsimony, dude, or like Occam's razor, dude. There's way more things needed for relativity to work, or the heliocentric model to work, like expansion, time dilation, dark energy, dark matter. Like, bro, like the list goes on, dude.
Okay,
Bending
so
and warping
of all those things, which one does Aether answer? All of them? Is Aether the unifying field theory? So Aether is like the unifying field theory.
Yes, dude. You could have a unifying field theory, right, from the quantum scale to the cosmic scale, but you would have to go back to the drawing board and return to pre-relativistic days, which they're not willing to do, bro. But if they did, they would realize that the same force that works at the quantum scale, like the intermolecular forces, Euler forces, is the same force that works at the cosmic scale.
So that's the reason why electromagnetic forces work at that scale is because of the amount of mass that's there, because they're not super powerful. When we see these things at that scale, gravity is the only answer to that math, right? None of it bleeds out to ether or anything else like that. And like I said earlier, ether was proposed in the past as a medium that light had to pass through. That was the luminous. That's what ether was to them. What you're proposing is something fundamentally different. That's why I said, is it the unifying field theory, right? Like it is not just what it was. So going back to what it was would be unproductive.
No, sometimes in order to progress, you have to take 2 steps back. No. You guys aren't willing to do that.
No, that's the thing. Like that's the thing. Like I said, why would we take 2 steps back towards a theory that was ignorantly created, and they couldn't? And I say that just because they lack knowledge, not as an insult. But why would you go back to that theory and not move forward into what you are trying to prescribe as ether?
Because you're
dude. Sometimes you have to correct course. You have to go back, and this is what you guys have to do, is to go back, because so dude, all the greats, dude. But you gotta understand, Lorentz, Sagnac, Michelson, Morley, Gale, Maxwell. They were all ether theorists, dude. They all subscribed to the luminous ether. Dayton Miller.
Okay, so
all of them, dude.
Ryan, remember what I said? That ether is not the same ether you are proposing.
How?
Do you not understand that part?
How, buddy? You keep talking out your ass. How?
I'm not going to answer you, Don, because you are.
You don't have an answer. You don't have an answer.
Yes, I do.
No, you don't.
If I answer you, will you shut the fuck up? Will you shut the fuck up?
So Omnivore did the little breakdown. Remember when Omnivore the breakdown in here the other day, man? Well, you had a chance to answer. Now you're just meditating.
So it's no question.
Omnivore
is a yes or no question.
You should have been checking out the little spreadsheet that we had.
If you won't shut the fuck up, I won't answer it.
Oh, you're mad. Okay.
No, I'm not mad. I'm just asking if you'll shut the fuck up.
Could have been talking already.
Answer your question. If you'll shut the fuck up, I'll answer your question.
I mean, if you'll talk, I'll shut the fuck up. But you're not talking.
I was speaking, and you started.
You're not saying anything. You're blowing hot air, bro.
The luminescence ether was a theory that was projected for the movement of light, because people did not understand that light could move through a vacuum. That's ether. That's luminescence ether. That is not the ether that's you're prescribing. You guys are prescribing something that's more like the unified field theories, things like that.
So this is the thing Witsit earlier brought up, that the idea that you have this vacuum, right, it hasn't been substantiated, especially because there's been multiple experiments that even in a vacuum that there's impedance. There's impedance.
But do you agree that is not the same ether of the luminescence ether?
No, dude, they're still trying to hold on to this, man. You got to listen. They've been here all night talking about this. Omni showed you this spreadsheet where it was like the relativity versus the ether. Remember that spreadsheet Omni showed us? It had no differences to the luminescence ether, bro. It's just a new name. Everybody's saying it. All the Sabine videos, all these guys, they're letting you know it's the same shit with a new name, bro.
The only difference is that most of those guys, they consider the ether to be stagnant. Not all of them. But even
Well, I
there
do
was
appreciate you
like
saying the
Kelvin.
light propagation attribute. Thank you for making distinction that you believed it is, but that's not a deal breaker to me. They still hold on. It's the background fabric of everything, bro.
Yeah, Kelvin believed in where we get Kelvin from, dude. He believed in the vortex theory of ether, dude. So, you know, depending on who you're talking about, like they were trying to figure out reality back then, dude. Einstein just came in and basically flipped the table over, dude. And he's like, nah, we're gonna throw this ether shit out and we're gonna call it relativity and space-time, dude. That's what happened.
Not really, right? I get what you're saying in regard to that.
The speed of light in a vacuum.
And the people, and the thing is think of a vacuum as a place where there's no friction or very little friction. And then those frictions will be particles, right? Like of atmosphere and things like that. Within that space, I'm not denying what you want to say or think. What exists in that space of frictionless, what forces could be at play there. But that is not ether. That is not the luminescence ether. Like I said, it's a different thing. So it's not about going back and trying to correct the mistakes of the past. It's about moving forward and trying to identify those forces or those dimensions or whatever the crap they are.
Can I just ask you quickly?
What's up, buddy? Cuzzo, where you been?
Yo. I've been taking time off. It's downtime. It's winter here. It's very cold in the south. But how are you dealing with the propagation of light then, if you're just without the ether? Baseline question.
I don't know how to answer that on the propagation of light, like how it moves from point A to point B.
Yeah, because it's a wave function, right?
Mm-hmm.
So
just because it's a wave, like you turn like a wave, like a water wave, and it's not water, like is that the question a bit?
So light is the characteristic of a wave function. It bears out those characteristics, right?
Yeah, but it's not like a wave, like a water wave. It's not like there's no physical need for it to be a wave. You know what I'm saying? There's no physical medium that needs to happen for it to come a wave.
But it does. Like, I mean, if you've got a source of light that's emanating and it's moving fast away from you, then it stretches into the broader spectrum and it shifts towards a redshift, right? This is the whole notion. So you need the medium in order to explain the phenomenon.
Like I said, I don't know. Like I said, that was the luminescent ether, what you're talking about, Riksky. That there needs to be some sort of material, some sort of thing that this light is moving to because of waves. I know that radio waves and light waves are not physical, are not like physical waves like an ocean wave is. I know there's a difference there. And I don't really know how to describe it right now, but I've heard it before.
Yeah, that is basically the precipice of perception, so far as I've come to understand anyway. Even the wave, like you refer to the wave of the ocean, it's just made up of those, the particulates of the water behaving in such a manner, such that you can call it a wave. But the wave itself is actually not a thing, which is, I will sort of, is it Dyslow, I think, sort of presented this stuff to me. So that's my citation. It's very interesting because a wave is not a thing then. It's not it's not an object, it's not material. It's almost like it describes the way that the material behaves. Then if you want to ascribe that to light itself is not a thing, it's just a behavior of some sort of substance or something that sits, I don't know, as a like the perceivable action of it. So light is just the perceivable action of the ether at that point.
I mean, that's theoretically something that, like I said, that when you, like I said, like when I was saying earlier about frictionless and friction, right? If you were to prescribe any quality to space, I would say it has very little friction. And what I'm saying is, and if there isn't an ether, that's where you would look. And then, like do like the test to see, if it moves or if it doesn't, or if it has different temperatures or all those other little things. That's more of the classical luminescence ether look. The ether that's always being proposed these days is not that concept. You're talking about the historical concept of it.
How is it not, Rene?
Like, I mean, like if you just look at magnetism, this ability to create work or torque transposed through a magnet, copper, windings, electricity, this relationship between electromagnetism. It has a viscosity to it, a sort of a substance to it, if it's energized in a certain way, obviously. So it's almost like there's a substrate there that if you go ahead, sorry.
Rene keeps wanting to make this distinction about this light needing to propagate through something attribute. It's like they're still holding on to that, dude. They're saying it's nothing completely empty. They're saying they have a substrate or whatever, some sort of field different than a space-time field, a more interacting with the fundamental forces field, Rene. It still is something light would be propagating through in this new model.
So science has to be testable and repeatable, correct? Or am I incorrect with that assumption?
No, I mean, the universe doesn't have to be, but if you want to continue to make if you want to make predictions, it needs to be testable.
Okay.
What did you say?
Predict it.
What part of what you said is testable?
They're working on it. It's all testable. This is the same thing. Like, listen, if I'm flying around a forest and there's a tree in the middle of the forest,
so you don't have to do that. You can just tell me what part of this is testable.
Bro. I need this philosophy right here.
No. You do this all the time. You always yell at people to get yes or no answers and stuff because they don't want to answer the question. And I'm just asking.
No, you didn't ask me yes or no. You're asking me open-ended. Which part isn't a yes or no? You failed again. So anyway. Right, so let me go on. So anyway, bro, you're gonna make me lose my train of thought, bro. It's not fair. So anyway, where were we? This philosophy of this testable, bro. Where's the center of the absolute coordinate system? Just because you're flying past the forest so much, you can't exactly lock down where that tree is. That tree is still in an exact place. I'm sorry, you don't understand that concept.
So you didn't answer. So what part about what you're talking about the ether is testable?
So matter if it's testable or not, it can be right whether it's testable or not. You're not going to make predictions. Okay. You might not make predictions from it, but it still could be right.
Okay.
And they'll figure out how to test it in the future, Rene.
So what's been delivered to you is a model that has, Newtonian problems, and Einsteinian in physics in it.
Problems
right?
That the ether cosmology
that model is testable. That model is repeatable.
And it's failing. No, it's failing.
And is your ether idea going to stop any of the failings, like other things that make it fail?
They're absolutely trying to reconcile these things. I'm sorry, you don't want to keep up with the Sabine videos, bro.
Okay, so I'm asking you, what would ether or whatever this thing is? I don't know what it is, right? We'll just call it ether. What would ether stop in the failure of this model?
Well, you should go to the spreadsheet that Omnivore has.
So what is that? What would ether stop?
Yeah, like frame drag. Like
what does that mean? Like, what would ether stop? Would it? So it's a viscous medium that interacts with something. What would it stop as far as like its performance of resistance or something?
In this model,
what would correct? What would the ether correct in the existing model?
Well, what is it? The space time sort of whole bullshit. I'm trying to get my head around your. what would the ether like resolve or solve of the problem
Mhm.
of our current understanding of what space-time medium or something?
I guess I would say what would John said that it fails right over and over, and my question was, what would ether or whatever this finding is?
I think it resolves the issue of mass. Like there's this whole idea of like gravity and mass. How do I say it? Reconciliation of these things are just not necessary.
Simplifies it.
It's right
Simplifies
there
it.
in my like. It's beyond my sort of scope of being able to sort of. What does ether
There's going to be a
solve? Like you're
presentation
looking
on
for
it
ether
today.
to solve something, and it would turn out actually that the ether's been like the concept of the ether has been around for a very long time. It's the old thing, right?
Well, that's the thing. It's
It
different.
was
The old one was for the propagation of light, and what's being proposed now is more like a unified field theory.
It doesn't matter that they were chasing one attribute, dude. It really doesn't.
I get that.
It's like back in the day, they had ice and they had water vapor. Now they have 15 different ices. Not that big of a deal.
What I'm saying is that it is a big deal, because Lyon said that we need to go back to the past to correct our mistakes, and that's not the mentality, and that's how we get
happens all the time.
But that's how we got down this road, and it is a big deal because the luminescence ether and the ether that's being proposed are two different things.
It's really not, dude. You keep saying it, but you're not saying
it. It is interesting. Like, well, I mean, okay. So as far as the historical concept is concerned, right? Are we moving forward into the future and we're creating more and more understanding, or are we creating more and more confusion and conflation and sort of issues into the future? So far as the progression of society is concerned, is that generally the dilemma that you're referring to? Like, we're asking the question, what does ether solve? It doesn't necessarily need to solve anything. It's just something of the past. Maybe we've created so much confusion and conflation in this time period in our understanding of the concept of the world that we actually need to take a step back in order to move forward. And I don't know about you guys, but I've had to do that many a times in sort of design and work that I've done. It kind of does make sense that, you know, you take 2 steps forward, 1 step back, that sort of principle.
I get what you're saying, but the thing is, it's if we understand that light can move without a medium.
You can't understand that. You don't know that.
Yes, we do.
Light cannot
no, you
move
don't. You've never taken
medium.
away the ether, so you don't know that, dude. This is ridiculous. You are doing a great job, by the way, but you know, I think you're just starting.
But light doesn't even move. It's not light does not move
light
itself.
Travels. Light travels.
How do you know that?
I don't want to get into this level of fucking incredulity, please.
No, dude, no. This is honesty here. This isn't incredulity. You haven't
how do we
proven
know
that you
that light fucking moves? How do we know that light travels?
How do you know you have a vacuum, Rene? That's the question. How do you know you have a vacuum, bro?
Friction. Remember how I said friction? You have less friction higher up.
Have you ever heard of a Bose-Einstein condensate? There's no friction, dude, and it's still material there.
Condensate. Say it slow.
A Bose-Einstein condensate, man. It's like, you know, these new forms of phases of matter. They are frictionless.
Okay, I don't know what those are, but if you're proposing that the state of the material that's above what we call the stratosphere is all Bose-Einstein condensate, you could prove that by showing a material.
Dude,
you can't do that because there's a material.
You first of all, you need to show that you have absolute zero friction. You have a low amount. I
said low friction. I literally.
Yeah, well, there you go. If you have any friction, you don't have a vacuum, Rene.
If you have and that's the thing, in space, you can say basically there is no friction here.
Look, man, I'm so sorry, dude.
It is. You don't have to apologize. You just have
you're down a rabbit hole right now.
No, that's the thing. So you're not going to sit there, grandstand, and say these things. Not at all.
No, you've not proven a vacuum. Your atoms
I haven't
swell
tried
up,
to prove a
bro.
vacuum.
What
did I say? I didn't say. I said
how big are your
less
electron
friction.
cloud, bro?
I said friction
You're
and less
saying that
friction,
there's
right? I
nothing
said friction and
between
less friction.
electron cloud and electron cloud. You pretend that because your instruments
If
aren't
those two,
sensitive enough to find anything, that there's nothing there. Okay, that's fine. So you have faith in the sensitivity of the instrument never getting better. Okay, that to me
that's
seems
not what I'm
closed-minded.
saying.
What seems closed-minded?
So if I have two electron clouds, that means I have two atoms of something. If those two atoms of something are going to interact, they will potentially bond. If say they're two noble gases like helium, they wouldn't bond. And there's no space between the two because those electrons, there's no connection between the two because those electrons won't be travel around the cloud of the other like proton and neutron cluster, So that's common fucking sense. That's just reality. That's understanding very basic fundamentals of reality and just looking at something and being like, I'm not a fucking drooling moron.
No, you're jumping to conclusions.
Okay, Rene,
you pretend the vacuum's there. You pretend you've been to space. You pretend that the atoms aren't because your instrument can't pick them up. These things aren't bouncing off of each other. What if they're all radiating out spherically, right? Everything up towards space is just radiating out spherically. It's not going to be any sideways it'll look like maybe you have a flow. So like if you're in the water, if you're in the river and it's just flowing, it's like nothing's there. It's just hubristic to me, man, to be like, we've proven that there's a vacuum guaranteed. It's just funny to me.
I said friction.
Job.
I said friction and frictionless, right? I said friction and frictionless. I said there's more friction and there's less friction. Friction
so you don't have a vacuum
by interaction with particles.
Right. So you have light propagating through things everywhere. There are things everywhere that the light is going through, my man. And even if you can't
and that's what I'm talking about that to quote Dave Matthews, that space between when all the particles and everything else is removed, right?
You haven't done that. When has that happened?
That happens. It happens to a very, very high percentage of particles being removed.
No, you said all. See, this is what I'm saying. You can't have your cake and eat it too. And even if you have no friction, dude, they're still going to propose light. Look, your space-time is nothing. Just because your space-time is nothing and their Aether is something, they think it has a field. You know about quantum field theory. There's like 20 different fields, dude.
Don, there is nothing that is 100%. Nothing on our planet.
You shouldn't speak of it as if there is, then, sir.
But what I'm speaking of it to is as close to perfect as we can make it.
Don't talk about it being perfect.
Okay, so every time I speak of a vacuum, I have to say 700,000 words to speak to your.
No, you could just say 3, and you could stop strawmanning your opponents because your opponents are telling you.
3? Can you tell me what 3?
Your opponents are saying, look, you think that there's absolutely nothing there. What 3 words? Yeah, the 3.
And I would say no to that statement. Just like that's why I brought up friction and friction. That's why
you mean an area where there. You mean an area where there's things there. Instead of about 3 words. Very thin. Very thin thing.
That doesn't make sense. That doesn't make sense.
Well, you shouldn't speak. You shouldn't speak nonsensically.
I say things that make sense, and you use.
No, listen. You're lying, Rene. You're lying. Listen.
No, a lie is for my intent to deceive you. You don't have a vacuum. Deceive you. I'm not attempting to deceive you.
Even if you think, listen. Even if you think
of lies,
no elements from the periodic table, even if you
friction and frictionless, right?
Okay, cool, dude. I'm going to try to steelman you, but regardless, it doesn't take away the Aether people thinking that there needs to be a field there, right? Your space time is absolutely nothing. It's not even a field. Like, bro, come on, bro. It's a nothing.
Okay. It's
your one and it's your one and only field, right? Like it's your one and only field.
It's a gravitational field, if anything, right? So
the quantum field theories have multiple.
What causes gravitation then, Rene?
Mass.
Yeah. So it requires mass to then propagate.
No, I don't know.
Therefore,
I don't know. I
there's
don't know how to chicken. I don't know how to chicken or egg it, right? But I would say the more mass, the more gravity.
just like what's waving the like what's causing the wave to be able to propagate throughout this vast
That's the question of
universe?
the.
Like
That's the question of the ether. That's if there's an ether or not. That's the question. That's the question right
precisely,
there.
and it would seem to me that, like, if we can sum it all up a little bit anyway, the materialistic worldview actually doesn't have a substantial result for that. Doesn't have an answer.
It does because light can move through a vacuum, even though it's not a perfect vacuum.
So because light can move through a vacuum, so a vacuum is what exactly? A lack of substance?
Area that has very, 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 very friction.
And we should just say electromagnetic can travel through a vacuum because we're not just talking about visible light.
Yeah, of course. But I guess, like, when it comes down to us being able to perceive something, we talk about light for that reason, right?
Yeah, well,
yeah. So then it lands upon something, it hits off, reflects, and then you perceive it. Just trying to get my head around this idea that you think that light, Rene, you agree that light is a wave function, but that it, as a wave function, your understanding of waves, how they operate, they need to propagate through a medium. And you're presenting the notion that there's a lack of substance, a lack of medium through which they propagate.
Like I said earlier, when we were talking earlier, there's a difference between, like, I think they call them mechanical waves. I think that's the word. And light waves and radio waves and things like that, right? There's a difference. I don't truly know the minutia of the difference. But the fact that light, which is a wave, moves, the fact that radio waves, all these other waves literally move, there is a medium in which they're moving through in our atmosphere, but we shoot them out of our atmosphere and we make the assumption, due to our findings, that there is no atmosphere up here, there's no medium up here, there's no materials of any level of substance that we can detect for the movement of these waves. If you can find one, you'll make a lot of fucking money. But at the same time, like that's
not how you make money, bro. We all know that's not how you make money, dude. You can go on OnlyFans and make money. Okay, you can't resolve the issue of light and expect to make money. Okay,
I'm saying, like, that's not the only way to make money. But I'm saying if you
but money and the connection with good ideas, like, they're discombobulated at this point. Good ideas and money and profiteering are completely separate from one another.
Yep, networking is what makes the money. Stealing a good idea from someone else and having the money to implement it is what makes money.
That's a good. That's one way people. Private equity funds do that all the time. You have to be very careful with those types of individuals. But yeah, that's one way. But I'm saying, if you can identify the substance in which propagates the movement of light, you will make a shit ton of money.
Or you could find yourself in a pretty sort of, shallow grave, right? Because if you get in the way of someone else's profiteering motive, that if you get in the way of someone else's profiteering motive, that you'll be dealt with, right?
No,
that's how money works.
Not knowing. How do we profit right now from not knowing how it works properly?
Yeah.
Because, I mean, what is it? There's the reason why you pay for something is because you're looking for convenience. Convenience lends itself to sort of an ease. So you're just basically lubricating the system in order to sort of liquidate it, essentially. And that's a transposition of creating value in the world as you as a human being. And you think that because you come up with an idea that solves a whole bunch of people's problems, that would necessarily, I mean, part of the aspect of this society is actually to create problems in order for them to sell you the product, right?
Okay. In no way did that answer the question. You said you're stopping the people from making profits if you find out how light actually works. How are we profiting right now from not knowing?
He did not say you're stopping people from making profits.
He said there's money being made, and if you are to come up with these answers, you may be dealt with because money will stop being made. So Don, please stop. Just listen, buddy. Just listen.
No.
Well, yeah, just like an electrical charge.
No, I will not listen.
An electrical charge is like generated through resistance, right? So, I mean, like, gold has value because there's resistance to the ability to generate it or acquire it.
I don't think charge is made because of resistance.
That's why they charge you. It's a surcharge. You don't get that?
Was that a dad joke?
No, his dad jokes are funny.
It makes perfectly reasonable sense that your economy is based on essentially a lot of the aspects and characteristics of nature through which you live. And when you look at nature, it requires resistance, and it uses that resistance in order to generate value. It's a very sort of broad terminology, but
so nothing to do with light at all. Okay.
The reason why the fan turns is because there's a resistor inside there that turns the electrical energy into a kinetic energy, and it rotates.
What? Resistor.
That's why you can.
Like the electric engines don't require resistors.
I don't know. Is anybody disagreeing?
You don't know what
layman figured out how to solve something like this? It wouldn't get his life in danger or something, or there wouldn't be people to come take the profit from him. Does anybody agree with Rene that if you could figure this out, you'd be rich? Does anybody agree with Rene, or do y'all agree with?
Yes.
Okay, so
you'd certainly win a Nobel Prize.
No, no, definitely not. People end up in shallow graves, as I said before, for presenting ease of information and technology. The provision of energy is the major social control right now.
Just get a Nobel Prize.
How is knowing how light actually works?
I gotta get in here somehow, dude. Without resistance, how could you harness energy?
Exactly.
Resistance reduces your ability to harness energy.
That's what he's saying.
There's no such thing as far as I know, dude. Unless you want to violate the law of entropy of thermodynamics, right? There's gonna be some type of heat. There's gonna be some type of friction, especially when you're trying to harness energy. There's gonna be friction. There's gonna be, whether it's propellers, right? Whether it's a piston, there's gonna be some type of heat. Right, i.e. resistance. You can't. There's no ballast. There's no harnessing of energy where you're not gonna have resistance.
This is some weird fucking electronics fan fiction, man.
I didn't say that, but it's still the bane.
Actually, alchemy
of energy production.
If you want to think about it that way, it's definitely alchemy. I mean, dude, you eat carbohydrates and you go and perform actions in the world. You're basically turning matter into action.
That's why with wires, bro, you got to make sure you got the right gauge and car audio. Because of resistance, dude. You're gonna blow a fuse, bro. You're harnessing electricity. You're running it down a tube, essentially.
Can one of you guys translate what you're trying to talk about?
Space is fake and gay, and essentially you need a wave function in order to solve your problem. So you need some sort of substance. Therefore, space is fake. Congratulations.
Brilliant.
Think about a waterfall, though. Right?
That's what I expected from you, but anyone else?
Or friction in the rotor, which is resistance.
Think about a waterfall, right? And then connecting a wheel to it.
Don,
like back in the mill days.
Speaking about.
Hold on, back in the mill days, right? You get hydro energy. How do you get hydro energy? How do you tap into that? Fundamentally,
you need to translate what you're talking about.
Well, I'm trying to break it down, dude. In layman's terms, you got a wheel.
Okay.
You got a waterfall. You got a waterfall.
Lion's got a point.
You got a waterfall.
I need your conversation translated for the room.
I'm not even using
it sounds like total gibberish.
That's what I'm saying. I'm not even using fancy words, bro. I'm using a wheel. I got a wheel.
We got a water cycle.
The wheel has paddles on it. You said it was fan fiction. So how do you tap into the energy? With resistance, dude. When you apply the wheel to the falling water, those paddles right? They cause what? Drag, friction, dude. And then you get torque. Voila, you have energy, dude. So I'm asking the guy about how can you get energy without resistance? And he still hasn't responded. He's like, oh, that's not what I'm talking about. So what are you talking about? Go ahead.
Where? Rene, do you know what you're talking about?
Usually I hear this stuff from the flat earthers, right? Like over unity, right? Where frictionless energy. So I'm wondering, where do you get this frictionless energy, dude? I'm wondering, where does that exist?
I don't think anyone has
Who
proposed
said that?
Ryan. Yeah, I don't think anyone's proposed that. But you are correct.
I said friction. Well, I didn't say friction. Friction and resistance are bad for generating and transmitting energy.
No, they're actually necessary for transmitting because every receiver is a resistor because it resists the energy and then it creates the flux by which you can like read the voltage.
Flux capacitor.
Something like that. So yeah.
He's talking about efficiency, right? Because there's a certain amount of dissipated energy or wasted energy, right? That gets transferred into heat. I get that, dude. That's a separate topic.
Well, no, that is friction.
No, well, it's not. Well, not. I get what you're saying, but not. Some of it is transferred to. Some of it is transferred to mechanical energy. Right? Some of it's transferred to heat, or completely dissipated. You don't even actually get to harness it.
Yeah, no, that's 100% true. But what's being talked about with friction is not that though. That's not what we were discussing though.
Well, that's resistance. Friction and resistance are synonymous.
I would say they're very closely. I wouldn't say synonymous, but you can use it like when people can't get their payments. Like in the industry, they'll say there's friction, and one of the things that we offer is called frictionless payments. But like it's more of a term. But you're all right. You use those measures to help harness energy. You are correct there.
Or like if you're running, dude, right? Like if there was no friction on the ground, right, you wouldn't get anywhere. If there's no friction, you're not gonna have any torque.
You couldn't transfer your force. Yeah.
Yeah, but it hinders energy production and energy transmission. Yes, we have it. We can't avoid it. But they try to make as little friction as possible in the bearings of the rotor. And if they could make zero, that'd be even better.
Because the bearings of the rotor is just it's just transforming, or is it transmuting the information, the kinetic energy to another location? No, because the tire, like at some point, the rubber needs to meet the road, right? So if you're talking about the engine creates the kinetic energy, it goes through the transmission.
We've all heard of cars and walking before. What are you talking about?
Because all of those, like, if you're talking, are we going back to light?
Why are you talking about cars on a road?
You also have, you have resistance, you have friction, and you have impedance. Earlier, Witsit was bringing up how even in a vacuum, you have impedance. And if you have impedance in a vacuum, that means there's something there, right? Where a vacuum traditionally is an area devoid of matter. Yet, how do you have impedance in a vacuum, dude? There must be something there.
So find it and identify it and label it.
We say the mass is there. We say the mass is over there, making a force, pulling stuff through empty space.
Lion, we're not claiming absolute.
Why are you pretending we're saying nothing's there?
Yeah, the problem is Lion is claiming absolute. We don't never claim an absolute. We say there's something that was water matter, but we don't say it's absolute zero of matter. It's there, but it's
no. I'm not even.
He's got it wrong. Whatever the medium is.
Yeah. I'm not even saying that the medium is made up of particles, dude. Right? I'm not saying that. And I know you guys believe there's like one proton, right, every square meter, and you're saying, well, that's why there's some type of friction.
No,
dude. I'm not even talking about friction. I'm talking about impedance, dude. Impedance. Even in a perfect vacuum, there would still be impedance, dude. And it's been demonstrated in the lab on Earth.
Why
The
do
only
things
the
fall to
only
Earth
word the
when
only thing
there's
I've ever heard of impotence is like
when
when
there's
you can't
nothing
get your dick
there?
hard. Like what is impotence in this? Like what is this? Like what is impotence? I do not know. I've looked it up and it won't tell me. My AI doesn't know.
He's trying to say impedance.
Oh, okay.
Yeah, well, I'm from the East Coast, so I was saying impotence,
Oh
but
my God.
impedance is probably the right word. Either way, bro, tomato.
No, you said it fine, but what does it relate to?
Resistance.
What are you trying to debunk? What are you trying to prove?
The fact that we've got a propagation of light through a vacuum that is nothing.
And what's wrong with that?
Because you've got no means by which to actually
Why the fuck
transmute.
do we need a medium? Just because flat earthers have heard the word ether, why does that mean in reality you need a medium for things to travel? What
are you
why are you
why
scared
are you
of empty
transposing into
space?
this whiny, complainy sort of tone? Like, what's going on here?
Because you're all speaking gibberish, yeah, backwards and forwards, fake conversation. It doesn't relate to anything. None of you are trying to say anything. You're
Are
just
you pretending
disagreeing
like we
with
haven't
everything
listened
you
to you
say.
talk about Wicca magic or something before? Like, let us get our handle on this, man.
What's
Like,
that got to do with it?
this is at the ultimate, like the precipice or the circumference, the silhouette, the very edge of our perception of reality. Give us a little bit of a moment
Yeah,
to
so
try to
go
lay it
back
out
to
in
my
words.
question. Go back to my question. Why are you scared of nothingness? Why can't light shine through nothingness? Why not?
Because it's a wave function and it behaves like a wave function, and a wave function requires a medium by which to propagate. That's
said
the
that?
issue.
Hold on.
Because
Don,
that's
the
the
least of your
dilemma at hand.
That's the least of your worries,
You
though,
made it
is the
up.
propagation of light. Dude, you have spooky action at a distance. You have gravity, right? You got mass affecting mass at a distance. What is the mechanism for gravity at a distance? You know what?
We don't know. We don't know.
All right, that's fair.
We don't know, but we know what it does, and we know how to harness it. And light isn't a wave. It acts like a wave. It's just us trying to put it in a box. Light acts like light, and it's different than normal, as somebody mentioned, mechanical waves.
So it passes through. Okay, just imagine a wave. Like you put a piece of glass in the middle of the ocean upon the shore, right? Like you put you know that wave function is not going to pass through that piece of glass, like that solid object, right? But for some reason, the wave function of light does propagate through. It refracts through that the medium of the glass, but
when you knock on something that's solid, do you hear a sound?
Yes, there's a
That's
resonation for sure. Yeah, that's
but it's
sound.
usually a sharp sound that dissipates quickly, right? It's not unless it's a bell, which propagates that wave. Right?
I suppose so. What are you trying to incite right now?
You said solids don't transmit waves, but they absolutely do.
Solids do not transmit waves.
That's what you said. You said it won't go through the glass.
Then it's technically not a solid, then, is it?
No,
because it would instantly transmit the wave.
It's technically that you're wrong.
There you go. Boom.
What?
Gotcha.
You got me because you don't understand what you said.
Because a solid is you're looking at the propagation of what do we call light at that point? The wave function, information.
No. You said waves don't travel through
transmission
solids,
of
right?
information across space-time, like between the medium.
Getting back to what you said, did you or did you not suggest that waves don't travel through solids?
I don't know. I don't remember specifically making that claim, but
okay, I thought you
I
just
tried to point out there
that
the solid that you're referring to. Like, I mean, how do we define solid then?
The same way we always define solid. So, do you not stand by that? We're not going to define solid if you don't stand by that.
Yeah, I won't stand by that. If that's your claim against me, I don't stand by it. I don't know what the fuck you're talking about.
You said glass is a solid, and sound doesn't travel through solids. Or sorry, waves don't travel through solids.
Okay, that's why you're saying that. Okay, cool. I've connected
so you didn't
the
say
dots
that
now. Well, I mean, it comes down to whether or not glass is actually a solid. So, I mean, it's solidified. This is a linguistic
whether it's a
sort of
solid
battle
or
at
a
this point.
liquid or a super solid or super liquid. Do solids transmit waves? Riksky.
Yes. Yeah, you got to say yes, I suppose.
Good, thank you.
Do you think that they transmit the waves instantaneously or like just a little bit faster?
They start instantaneously. They don't. If they traveled instantaneously, no.
So it's like the state of the matter, which is what we call it. The state. It's what is that like? Liquid, solid,
solid, gas, plasma.
And plasma is the other one. Yeah, that's a funny one, eh? Plasma, because that's more interactive with the electromagnetic fields, which is kind of like etherically interesting, I might say.
So far as we know, we don't know anything that travels instantaneously. But I got to go to mute first.
Mel, you're back.
Do you care, Rick?
Mel?
Do you care, Rick, that if empty space that you don't believe in is a medium or not?
You thought we were talking about nonsense before. What are you asking about? Like empty space is a medium or not? Is that the summation of your question?
Do you care if empty space on the globe model that you don't believe in is a medium or not?
If empty space is a medium or not?
Yeah, say it one more time.
Do I
and then
care?
see if you understand the words.
Yeah, dude, this is all a linguistic battle and a like sort of a battle of imaginations going on at this point, and you've been indoctrinated into a certain. Yeah, it all comes down to some. Dude, we're talking in words. If you don't think this battle is a semantic one,
and you don't understand
everyone thinks this is like a mathematical one. It's crazy.
Why don't you understand my words if this is all linguistics?
Maths and words. They're important.
Math and words, bro.
The ether is a toy model that exists in our minds.
Did you just put a curious accent and then enunciate some words?
Hey, Mr. Linguistic, why don't you understand my sentence?
Maybe it's not compelling. Yeah, try again.
Maybe it's because you know you can't answer. Yeah, because the real answer is no, you don't really care if a model you don't believe in includes a medium or not in space.
Maybe you got it all worked out, Don. Maybe you know.
What exactly happens with a road? Is it pushing on the wheel?
No, well, I mean,
linguistics,
that's always
bro, linguistics.
That's always a funny one. Did the car hit the tree or did the tree hit the car?
Yeah,
space-time.
What a classic.
Just can't work it out.
Those are the hot questions, you know. Humanity's been asking itself for ages now.
Is in your reality, Rick, do you care if space is a medium or not?
If it's a medium or it's not a medium, do I care? Space is
on your model.
Even by your classification, it's not a medium.
No, I said on your model.
My model?
Yeah, the reality
of
Rick.
We're not talking about like space as far as like space travel. We're just talking about the fact that I move my left hand from here to there. I'm moving it through space, right? That's the definition of space you're using.
You can use any definition you want because I said your reality, Rick's reality. And then I said the word space, and you get to pick.
Yes, we live like we exist. We're a bunch of fucking souls talking about like this 3-dimensional reality or something. Like, what do you want from me?
Souls?
Do you care if space is a medium or not?
You're a materialized soul exploring through like the material. You're a Barbie girl in a Barbie world, okay?
Yeah, you're a biological awareness.
Why did you say all that? I'm asking a simple question.
Well, I mean, it is important that I think that's an important point these days in 2026 right now. If you can acknowledge you're a biological awareness, I think you've had a good day.
That's the bare minimum right there.
Right? But these days, some people can't make a simple point. They're so lost in complexity and language and maths, like you're saying, they don't even know what they're really talking about.
Yeah. And that's why I tried to ask one simple question, but even that was too much. Because it
I
asks
suspect
all of
this
that stuff you were
conversation.
saying. Do you actually care about the
That's not directed at
hypothesis?
you, Rick, either.
And then it was like.
Is that your interpretation of understanding or something? Like, just because you don't understand something, it becomes gobbledygook?
No. You spoke gobbledygook. I asked you if you cared about your own hypothesis,
That's
and you
just an
couldn't
accusation.
answer. You told me more gobbledygook. Well,
I mean, we are speaking the Queen's English, are we not, Dawn?
Can we reset, dude? Can we like get it going
Yeah,
again?
like Dawn's like, what are you doing, Dawn?
You try and lay out your hypothesis line on this.
Me? Dude, I'm out of this, bro.
Yeah,
I came in for like a second.
You were ranting about it. So what was your hypothesis?
I got triggered because I heard somebody say that you don't need friction to harness energy. And to me, that sounded retarded, so that's why I stepped in. But this guy was.
The claim was actually originally because Rick said that electric motors need a resistor. Right, that's what makes the energy in an electric motor. Right, I said no, electric motors don't require a resistor. And then that changed to Riksky saying, "Oh, it's actually resistance." Right,
what started it. The Ether is what started it.
Before all that,
dude, that was like fucking 5 hours ago. Ether thing.
Why'd you talk about a motor? Go ahead.
Because he brought it up. Because Riksky brought the motor up.
Why did you bring it up?
Sparkus, you're too tired for this. You're lost in whatever the last person said, and you have no idea what they're talking about.
Spartacus is the most lost out of everyone.
He's talking about resistance, right? Oh my God,
Yeah,
Zion.
Zion
literally said, "Zion,
gonna eat your own."
Are you
Dawn's trying to bring us back to ground zero.
Yo, Spartacus. When we talk, dude, Spartacus. When we talk about resistance, dude, it's not exclusive to resistors. I know that the word resistance is
how
it
was started.
But that's a retarded argument.
Riksky brought it up. This point about resistance.
That's a reductionist argument, dude.
That's Riksky's first example. How this?
But you're right. We don't need resistors
started.
We don't need resistors in an electric motor, dude. I agree with you there.
That
you
was
need
my
resistance.
only point.
All right, cool.
Which started this whole conversation.
Resistance is futile.
That did not start the whole conversation, no.
It did, Don. You don't remember.
No, he was trying to clarify what people were talking about.
Anyway, we should move on from this conversation.
I already managed to assume you were talking about light traveling through space because you were going on about gyroscopes and all that. And Aether.
Gyroscopes have got nothing or very little to do with light traveling through space. They're actually kind of two separate discussions, I believe, anyway.
Yeah, but they're all related to trying to debunk the globe, right? All the stuff the flat earthers.
Yeah, because the globe's fake and gay. Like, we've already established this. Yeah.
So that's a really simple sum up from you, but that doesn't explain the gibberish.
Yeah, the reason why light can't propagate through a vacuum. Yeah, that's what we're trying to get to.
You don't know that. Yeah, that's your claim. Yeah, I'm saying, do you actually?
No, that's your claim, and we don't believe
it. Or not? Do you care if it can or not?
Yeah, sure. I care. I'd care if you could show it, but I doubt you can do that.
No, you're the one trying to debunk it. Yeah, so you have to convince us that it can't.
You're
No,
the
that's
no,
you're
no,
the
no,
one
no,
that
no, no.
said you're the
You're
one
like
that
you're
said I
almost
want
like
to keep on.
this.
Don, the
Like
burden of
you
proof
say,
falls upon to you. The burden of proof falls onto the positive claim, not the negative claim, Don.
yeah.
Don't do
But
that.
Rick
It's your
said
it's
the
your word,
Dawn,
not
positive
his.
Dawn, you're
claim. If you listen
ridiculous, Dawn.
carefully, he made the claim.
This
I
is how
don't make
Glover thinks.
claims. I did not come here and say, hey, Earth's a globe, light travels through a vacuum. I'm not that dumb. Rick said, globe is fake and gay, light can't travel through a vacuum. He made the positive claim. Listen carefully.
There is no globe. There is only you, and then you're talking to another soul, apparently, across
That
the
shows you
surface of
haven't
the
got any
earth.
evidence for your claim.
No, actually, like you need to prove your evidence, dude.
No,
There's
it's your
no.
claim. It's your claim.
This is
So
a neutral
here and tried to
territory. This is
poo-poo
not
someone's
globe territory.
model
Okay.
that's been alive for 2,000 years. You tried to poo-poo it. That's you. You're on the spotlight claiming things.
For how long have I been trying to do this? How many years?
For 2,500 years, the globe's been accepted, and now you're here to poo-poo it.
Dude,
and then
Dawn,
you think you can turn that onto me trying to prove it.
Dawn, I'm an individual. 2,500. I can't even imagine what it would be like to live that long. Please, like, why do you do this?
The globe model has been here for that long, and you came to poo-poo it.
You don't know that.
So it's you
That's a lie.
making the claim.
You fucking woke up yesterday.
Hold on.
Why don't you understand?
So you did say something that I want to challenge. Also, you hold on, Don, please. I'm trying to ask you something, Tarek. You said that waves can't move through a solid. Where'd you get that idea?
Who told you that I said that? See, this is the thing. Like when other people say that you said something,
like 5 minutes ago.
Oh, give me a break. What did I say? Waves can't move through a solid.
Yes, you give an example.
When it came to the relationship of the notion of like putting a piece of glass inside of the, if you go to a beach, you put a big long piece of pane of glass in between like the beach, the waves, and you watch them crash. They won't transmute the information across the glass, right? It creates a resistance, a barrier. It was all to do with that.
There's still okay, but
it reduces.
You understand that waves, like earthquakes. You're talking about earthquakes, dude. That's a wave that's being transferred or propagated through the crust, right? Or in water, or in glass. It doesn't matter, or in steel. Actually, the more solid the object, technically, the faster the wave can move when it's sound. Sound waves can move faster through a dense object than.
What I was trying to communicate there essentially was that we've got waves upon the ocean and we talk about light behaving in a wave-like function. And yet what we see is that light can pass through glass and we describe it as a wave-like function. But if you put a pane of glass in the beach, you watch that solid resist the flow of that wave of that ocean. So the language fails to obviously present itself for the means by which I can communicate that to you guys. Like the definition of a wave at the ocean is different to the definition of the wave function of the light, right?
You know, there's different types of wave, right? There's compression waves. Are those sinusoidal waves? I forget what those ones are called. But what type of wave is light? What does it travel?
Well, what's the medium that it's excitating?
No, that doesn't matter.
You don't think that matters?
Right. Light is always the same type of wave. Which type is it?
Light is always the same type of wave. Which type of wave is it?
What the fuck
is it a
are you
wave?
talking about?
Yeah, there's compression.
It's an electromagnetic wave.
Yes, and what type of wave is that? There's classifications of waves.
What class of wave?
So a compression wave, an expansive wave, a lateral wave, like proper.
Depends. It depends on the source, doesn't it, Chuck?
What are you talking about?
Wavy, man.
You've gone back to hypothetical mediums and traveling, but what is it related to? Which model?
This is overlay from Eggshells and Witsit and Taylor and Lyon debate. discussions.
But light is a transverse wave, which is not the same wave as an ocean wave, right?
Yeah, that is useful information. But that would be us trying to prove our claim.
No, I know. It's just, but you're trying to prove your claim. You're trying to prove physics to somebody who doesn't know.
No, I'm saying, why are you even questioning that at this point in
Yes,
your
but
life?
you're questioning high level physics for somebody who doesn't know basic level physics. That's what I'm
No, I'm saying to them, why are you questioning that? What do you think you can
Because they
get
don't-
out of it by speaking gibberish for hours about mediums? What do you think you can get from that?
No, you're just simply like antagonizing the interpretation because
The
you're
thing
a
you've said is
perceptible
fake and gay
being.
already.
Yeah, it's so fake and gay.
You're
Yeah,
comparing
but
two-
why would we
you're
listen? Why
comparing
would we
two
listen
completely
to any
different
of
types of
your
waves.
Calling you on
distractions?
Well, you go listen to like astronauts docking with other astronauts, and you can get your rocks off on that. Okay, that's fine. Doesn't mean I have to
Why are you
subscribe to your fucking FM
Not
radio.
just, I need
Why
you to
would you
debunk
compare?
it, not speak gibberish about it.
Why would you compare two totally different types of waves and say they should act the same?
Types of waves. Okay.
Yes.
Is that what you were bringing up before? Cool. Let's go with that.
Yes,
Then.
that's why I said types of waves.
Yeah, great.
So are you just going with the two types?
Let's
How
help
many
us
types
to
of waves are there?
understand.
Tell us.
Yeah. I want to hear
not-
this
Tell us how many
types of
types of
wave.
waves are there?
I'm not sure,
And
but
you
there's more
should
than two.
define medium. It's funny, your definition of medium.
Yo, hold on, dude. Yo, tell us how many types of waves there are. Please.
There's more than two.
Well, just tell
Not
us,
when you
dude.
Google it.
Why are you holding us hostage? Just tell us.
I think it's at least